We have a particle starting at the origin, moves along the positive x-axis. And let's take a look at each part here. So we want the coordinate of the particle at 5 seconds. Now here's the thing, when we have a velocity versus time graph, the way we get the coordinate of a particle, we're really looking at the displacement, which is the area under this velocity graph. And this is 4 here, according to what we have. So let's be really careful. What I'm going to do is simply calculate the area here. So this is 2. So let's actually go ahead and look carefully at the areas here. Now there's a lot of different ways that we could get the area. I'm going to keep it simple. Each of these rectangles has an area of 2. So 2, 2, 2, 2. This is half a rectangle, so it has an area of 1, 1, 2, 2, and 1. So at 5 seconds, basically I'm just going to add up all my numbers. So I have 2, 4, 6, 8, 10, 12 plus 3. So the answer to A is 15 meters, because it's an area calculation. For part B, the velocity of the particle at 5 seconds is 2 meters per second, just reading it off the graph. And then for C, what is the acceleration of the particle at 5 seconds? Let's just get the slope. So the acceleration, I'll use these coordinates. So we have 6, 0. And here we have 4, 4. So we can say 0 minus 4 over 6 minus 4. It's going to be negative 4 over 2. So negative 2 meters per second squared. Now for part D, the average velocity of the particle between 1 and 5 seconds, that's going to be the displacement over the time, which we got 15 meters divided by this time, which is 5. So that's going to end up being 3 meters per second on average. And then if we want the average acceleration of the particle between 1 and 5 seconds, that's just going to be delta v over delta t, which is going to end up being 2 minus 0 over 5 minus 0, which is 0.4 meters per second squared. All right, so that's it for the additional problem, question number 2, and I hope that's helpful.